Hey guys, Danne here, and welcome back to Information Design. We are in week 5, and today we'll be looking at the difference between data visualization and information graphics, or infographics. We will also discuss the fine line between design elements and Chartjunk. We will then be chatting about how data is now being used to tell journalistic stories, being used in the arts, and we will look beyond just visualizing data. First, let's talk a little bit about the differences, or actually the similarities between information graphics, or infographics, and data visualization. This is one definition of data visualization. Data visualization is the presentation of data in a visual format. So we looked at this line chart by William Playfair a few weeks ago, and this is one of the first data visualizations ever created. It's definitely presenting the data in a visual format, but is it an infographic or is it just a data visualization? So this is a definition of infographic that I found. So infographics or information graphics are graphic visual representations of information, data, or knowledge intended to present information quickly and clearly. So it's very similar to the definition of data visualization, right? I actually like to add another line to this. An infographic is created specifically for the dataset being used. Technically, an infographic is still a data visualization, but a data visualization isn't necessarily an infographic. Florence Nightingale was a British nurse in the mid-1800s and is credited with creating one of the first infographics. She was working as a nurse during the British War in the East and created this infographic to break down the total number of deaths over the course of a year. Blue represents preventable diseases, red represents death by wounds, and black represents other causes of death. This was designed specifically for the data and to push the story she was trying to send to Parliament, that most of the deaths can be prevented by sending medicine. Also, since most of the deaths happen during the winter months, to also send blankets and warmer clothes. So let's take a look at some visualizations and see if we can define them as infographics or just data visualizations. So this is a visualization by Jared Thorpe. It's his New York Times visualizations connecting all the different stories as a node-based visualization. So I believe this is more of a data visualization than an infographic. Because it's a node-based visualization, you can populate this with any year of New York Times data, or even look at like The Guardian or some other news organizations and populate it with that data. So it's interchangeable visualization with different data sets. So it's reusable basically and can be used with multiple different types of data and multiple different data sets. So this is more of a data visualization than an information graphic. This is a great visualization using data from the World Database of Happiness and reflects how happy a specific country is over the course of 15 years. So this was designed by Good Magazine. They're using the smiley face as a graphic to help interpret this happiness data. So the actual smile, or maybe lack thereof sometimes, is a line chart representing that data. So because of the way this is designed, the way this is put together, this is more of an information graphic specifically designed around the data that they are visualizing. So if you put in other data like stock market prices or really anything else that's time-based data, it might not always work. It probably wouldn't work as well with other data sets as it would with the World Happiness Index data. So this is an information graphic more than just a data visualization. This is a visualization showing the largest corporate bankruptcies in history. Again, this is a piece by Good Magazine. It, again, is showing a visualization based off of a specific data set of bankruptcy data. So it's showing ships that are capsizing and sinking. A sinking ship represents the organization that's going under. So if you were to apply this to other data, it really wouldn't work as well as data specifically around bankruptcy when it comes to a company. So this is more of an information graphic and less of a general data visualization. Here's a spread from one of Nicholas Felton's personal annual reports. So this is kind of a collection of data visualizations, in my opinion. So we have a map showing geographic data. We have a pie chart that is showing parts of a whole, and then an area chart that is showing data over time. So all of these different types of visualizations can be repopulated with different data sets and still work. A pie chart will always be a pie chart no matter what type of data you associate with it. So the visualizations itself aren't really unique to the data that is being applied to it. So this is more of a collection of data visualizations than an overall infographic. This is a visualization showing the total number of pedestrian deaths by country. So the visualization is representing the data by the total number of shoes, which makes sense for this data set. This is definitely more a infographic or information graphic rather than a general purpose data visualization. So if we were to apply a different data set to this that wasn't related to pedestrians or walking or vehicle fatalities, then it wouldn't really make a lot of sense. So hopefully that exercise made it a little bit more clear what the difference is between information graphics and data visualizations. Again, in my opinion, information graphics or infographics are visualizations that are specifically designed around the topic or the data being used to visualize. So in my opinion, information graphics or infographics are designing a piece based off of the data specifically, versus a data visualization is more general purpose, like a bar chart or a line chart or a pie chart. Those are general purpose visualizations that you can apply really any type of data to, any topic to, and it would make sense. Versus an information graphic, you can't really take something that has already been designed based off of a specific data set and then apply a different one to it. It just wouldn't make sense. The visualization wouldn't uphold with another data set or another topic. Now, when we talk about information design or data visualization or information graphics, there's really two ends to this spectrum, and there are two people that represent either end of that spectrum. On the left, we have Nigel Holmes, and on the right is Edward Tufte. Nigel Holmes has been designing data-driven graphics since the 70s, mainly for magazines like Time magazine, among a number of other news publications. His designs tend to be very illustrative and design-heavy, although these visualizations don't tend to be necessarily 100% accurate when it comes to the representation of the data because of the design elements being used. But the overall idea is still very clear. If you were trying to see the exact difference between the values of the monster's teeth on the left, it would be pretty much impossible since it's skewed. We also don't know if we are just looking at the height or also the area. The same goes for the medical bar charts on the right. Edward Tufte is a statistician, an artist, and a professor of political science, statistics, and computer science at Yale. He is best known for his writings on information design and is a pioneer in the field of data visualization. He believes that data visualization should focus on being as clear as possible. To do this, he believes all design elements should be, for the most part, stripped away. In his 1983 book, The Visual Display of Quantitative Information, Tufte coined the term Chartjunk and used one of Nigel Holmes's illustrative charts as an example of what not to do. On the left is Nigel's chart showing the data for the decline in the diamond market from 1980 to 1982, and on the right is what Tufte believes should have been used and created instead. This idea has split the data visualization world in two: Holmes versus Tufte, design versus analytics, memorable versus clear. Now, I personally think a nice balance between these two worlds is necessary. The hard part is finding that balance. Luckily for us, Alberto Cairo, the author of our textbook, created a very helpful chart for us to use. This is called a radar graph, and you can use this to help determine if your information graphic is leaning toward the memorable side or more on the clear side. Let's take a look at each one of these individually. So when you're designing something and determining which side of the spectrum you want to be on, you really need to know your audience and know your user and know who's going to be viewing this. So is it going to be more of a scientific paper for scientists and researchers? Or is this going to be presented more to the general public in like a magazine or a newspaper? So that is a key component when it comes to determining whether it should be more abstract or figurative or more decorative or more functional. Understanding your audience and who you're designing for is really important. So we have to decide if our visualization is going to be more abstract or if we are going to be using more figurative graphics to interpret the data. So on the left is Massimo Vanelli's subway map, and on the right is a breakdown of the 2020 Mars rover. So the Massimo Vanelli subway map is much more abstract. It's looking at all the data in a more abstracted way. So the distance between each subway stop isn't necessarily 100% accurate. The geographic location of everything isn't 100% accurate, but it's a little bit more clear. Versus the graphic on the right displaying the Mars 2020 rover is much more detailed when it comes to the detail around the rover itself, the exterior, the interior, all the parts that make up the rover. So again, you have to look at the audience. So the rover visualization is more for the scientific community. They want to see all that detail. Versus the Vanelli subway map, which is more for the general public, it should be much more easy to navigate and probably more abstract. So next, are the elements we're using more functional or more decorative? So here's the information graphic displaying bankruptcy data again. So the elements in this visualization and this information graphic, in my opinion, are much more decorative rather than functional. The ships themselves, although the size does represent the value of the data, the accuracy isn't 100% correct. So this is more decorative than functional. Is the information being displayed more dense or more light? Here we have an infographic on the left breaking down the mega ramp in Sao Paulo, and on the right, a description of how a monkey hunts termites. So on the left, it's a visualization that has a lot of content. It's dense with content. There's information around the ramp itself, information around the elevator that takes you to the top of the ramp, information on wind speed and the types of skateboards that you would use to ride this ramp. So there's a lot of information in that spread. Versus on the right with the monkey hunting termites, it's a very simple visualization breaking down the basic process this particular monkey goes through to hunt for insects. So on the left, the mega ramp visualization is much more dense, versus on the right, the monkey visualization is much more light and airy. Does the design have multiple dimensions or just one? Here we have election data being displayed for a New York Times article. This is all one piece, by the way. So is this more multi-dimensional or unidimensional? So considering this is all one piece and there are multiple maps displaying very similar data, this is very multi-dimensional. We're looking at basically the same data, but on many different layers and many different views. So we're looking at state level, we're looking at county level, we're looking at choropleth maps, but we're also looking at centroid maps. So this is a very multi-dimensional visualization and a multi-dimensional story around the electoral data. Are the visualizations being used more original or are they more familiar? So this visualization is showing 100 million New York City 311 calls and what it looks like by the time of day. So this is becoming a more popular visualization, but it's still not as common as, say, a bar chart or a column chart or a line chart. So this is a chart that most people have not seen before. It's called a stream graph. So this is leaning more towards the original visualization rather than a familiar visualization. So a familiar visualization would be something like a line chart or a pie chart or an area chart, something that we've seen many, many times in the past. So a stream visualization is a little bit more original than something that we've seen before. And lastly, can the visualization explain many different things once, or is it redundant with the data? This is a visualization breaking down the process a wave goes through from creation to break. If you can read it, you can see that every step is repeating some previous information to make it as clear as possible. So this is leaning toward the more redundant side. It's repeating or being redundant with the information each step of the way. So it makes it very clear by the time you get to the end when it comes to the process that this particular visualization goes through. Real quick, I just want to talk about data journalism. Data journalism uses data and facts to help support any given story. It reflects the increased interaction between journalists and several other fields such as design, computer science, and statistics. Now, since I'm not a data journalist, I thought it's probably better if a journalist explains this rather than myself. So this is a video by The Guardian explaining what data journalism is. So I won't play that now, but I'll link to that in the description on the YouTube channel as well as on the class website. So make sure to pause this and go to that link and watch this video real quick to check out what they have to say about it. So the first example of data journalism at The Guardian dates back to 1821. It is a leaked table of schools in Manchester listing the number of students who attended it and the cost per school. This data was used to help show for the first time the real number of students receiving free education, which was much higher than what official numbers showed. Today, The Guardian is one of the leaders in the field of data journalism. Their story on the NSA files that Edward Snowden leaked to Glenn Greenwald, who was an editor at The Guardian at the time, is an amazing, award-winning, data-driven journalistic piece. I'll link to this in the description on the YouTube channel, as well as on the class website. So make sure you check out this piece and scroll through it. It's full of really interesting, detailed information. Although this belief that data in the newsroom is extremely important isn't just at The Guardian. The New York Times have been creating amazing interactive data-driven stories for years. A few years ago, they actually hired Mike Bostock, who created the D3 framework, which we'll be using in a few weeks in this class, to help them create better interactive visualizations. So this is a story that is mapping poverty in America, literally mapping it, and is showing you a breakdown of the federal budget per person and where that money goes. Again, I'll link to this in the description on the YouTube channel as well as on the class website, so make sure you check this one out too. 538 is a great news media company that came out of ESPN and was developed by Nate Silver, who was a sports journalist and statistician. 538 mainly focuses on sports and politics, but they also run stories around economics, science, and just general life stories. So I would highly suggest looking at them when it comes to data-driven stories for journalistic purposes. Lastly, pudding.cool is another great website to check out when it comes to data storytelling and data journalism. They get a little bit more creative when it comes to the topics that they choose to focus on for their stories. So one of them, for example, they were analyzing the difference between gene pockets in men's genes versus women's genes to see what the size difference really was. So it's a really great website to scroll through and look at when it comes to data-driven stories. Now, when it comes to presenting data, especially for the news, you have to think about the ethics behind what you are presenting to the public. There are 5 qualities that make up a great ethical data visualization. The first is to be truthful. All the data being used and displayed is based on honest and thorough research. Next, it has to be functional. All the visual interpretations of the data must be accurate and allows the user to pull out their own unbiased opinions from it. It also has to be beautiful. Make it attractive and engaging for the audience you are creating it for. Next, it has to be insightful. It allows the user to pull out any highlights that might have been difficult to see otherwise. Lastly, it should be enlightening. Data can be very powerful if your visualization can display the power of the data. Then it can change anyone's opinion for the better. Here is an example of a visualization that is misleading when it comes to the content that's displaying. So this is showing the jobless rate after the first 3 months, looking at Trump versus Obama versus Bush versus Clinton's administration. For one, it really isn't good to look at who's in office when it comes to the unemployment rates. There's many other factors involved. And 2, if you're looking at the unemployment rate at this particular time in someone's administration, you really have to credit the number to the previous administration. So the 4.5% should really go under Obama, the 9% should really go under Bush, and the 4.4% should really go under Clinton. At this point, Trump really shouldn't get credit for anything when it comes to the unemployment rate after 100 days. So this slide is showing two different maps. One is from the New York Times and the other is from Breitbart News. But it is supposed to be displaying very similar data. So this is showing the 2016 presidential election data and who won what areas of the United States. So the visualization on the left is showing the breakdown by county, and the visualization on the right, so it kind of looks like Breitbart just picked I don't even know if this is based off of real data. It doesn't look like it. If it is, then it's very skewed data because everything is red except for it's essentially the coasts. So this is very confusing. If it's supposed to be the same data, something is wrong here, either on the Breitbart side or the New York Times side. Choosing either the right data set to be 100% honest with how this is being displayed, and then also how are you visualizing this to be ethically responsible, to show the data in a responsible way, is very important. So whether you're the New York Times or Breitbart, you have to be extremely honest when it comes to the data that you're getting, where it's coming from, how it's being modified, if at all, and how are you visualizing it? Is it clear or is it skewing the message completely? So this is a visualization showing the same data of the 2016 election broken into different ways to visualize this geographically. So we have a chloropleth map. Well, these are all chloropleth maps, changing the color of each shape based off of the value. But this one is based off of states. This one is based off of counties. This one is based off of counties, but showing the range between red and blue. And this one is showing, I think, by counties as well, but showing more of a range between red and blue. So the bottom row is also skewing it, I believe, based off of population by state and by county, and then also doing the same thing by showing you the colors as a range between blue and red. So I don't really know what is the most honest or ethical visualization here. If I had to choose, it would probably be more towards this side, showing the range from blue to red, and then also I think showing the population as well, although this gets kind of skewed as well and hard to read, so this is kind of confusing too. So probably in this area for these, and then in this area for the not skewed maps, in my opinion. So here's an example of visualization that hits on all of the ethical points that we talked about earlier. This chart is comparing the temperature data in the northern hemisphere to data taken from tree rings, coral, ice cores, and historical records. The temperature data is displayed in red, and the other data sets are represented by blue. The gray values represent the potential margin of error for unknown data. Just looking at this, you can tell that the data is truthful since they are accounting for the margin of error. It is functional. It is beautiful for the scientific audience, which it was created for. It is insightful when displaying the data, and it is very enlightening. This single chart is responsible for making many non-believers finally understand that global warming is a problem that is affecting all parts of our world. You really can't argue with this visualization. Now, up to this point, we have been focusing on the visual interpretation of data, but we can't forget our other four senses. Sometimes visual interpretation isn't necessarily the best medium to interpret a dataset. You can also use sound, taste, touch, and smell to represent data. This is a piece by the New York Times that is representing the fractions of a second that it takes to cross over the finish line during the Winter Olympics. For some reason, we are much better at hearing the difference rather than seeing the difference between these values that are so close together. So when you click on play, it's actually playing the audio of each one of these, notes in that time that it takes for one person to cross the finish line. So it's worth checking this out. It was created in Flash, so it's very old. So you might need the Flash plugin. If it works, great. If not, I apologize. This is a beautiful piece that represents the data coming from Wikipedia in real time that visualizes it, but also uses audio to represent that information as well. So let's go ahead and check out that site real quick. So this is representing in a visual and audio format real-time Wikipedia entries and updates and changes and new members being created using their API. So the bells indicate additions and string plucks indicate subtractions. Pitch changes according to the size of the edit. The larger the edit, the deeper the note. Green circles show edits from unregistered contributors, and purple circles mark edits performed by automated bots. You also may see announcements for new users as they join the site, punctuated by a string swell. And you could also click on any one of these to see what the entry was. And it'll take you to that particular change. Wow, lots of changes going on. This is a project by a friend of mine, Annelie Berner. She actually took the World Happiness Report, the World Happiness Index data, and applied it to taste by basically taking the value for each country, how happy that country is, and applying that value to the amount of sugar that she puts into a cupcake. So basically when you pick up like Mexico or Argentina or Brazil or the United States in cupcake form and you take a bite, if it's sweet, it represents that that country is very happy. If it's not sweet, then that country is not happy or not as happy. So that's tasting data. Another friend of mine, Steve Cordova, created a project called Tactus. And he is actually red-green colorblind. And he wanted to create this device that can detect color and then interpret that in a way that he can understand. So what he did was he embedded a magnet in the tip of one of his fingers. Then he designed this device using a color sensor, microcontroller, this analog function generator, an electromagnet, and then battery to charge it. And basically how it works is that this color sensor can detect what color is it's reading. So if it's looking at red or green or blue, it can understand that. And then it's going to be processed by this microcontroller. And essentially what it's going to do is pulse a certain waveform depending on the color that it sees. So if it's blue, it's going to be a sine wave. If it's red, it's going to be a square wave. If it's green, it's going to be a saw wave. And what it's doing is that electromagnet is pulsing an electromagnetic wave that he could pick up from the magnet in his fingertip. So he can feel the color rather than see it. So depending on the sine wave, the square wave, or saw wave, or any combination of those three, he can feel what color it is. So that's feeling data. This project actually uses scents to replicate the events of 4 famous deaths. When Princess Diana died in the car crash, it probably smelled like burning rubber, gas, and leather of the car seats. So when you go into each one of these little cells here, it gets pumped those scents into that cell. So you could actually smell what it would have been like if you were there when Princess Diana died, for instance. Okay, now I know we are getting into more of an artistic expression of data representation. So let's just continue down that path of data art. So this is a project by a good friend of mine and my old studio mate, Rupa. It's called Grills. She took data from rap songs and visualized them as gold grills that you could actually wear. So this is a project by Josh Bagley, who's a data journalist and artist living in New York. This particular project uses Google Maps to visualize the landscape of all the known US military bases around the world. Oddly, the majority of them you could see fine on Google Maps. There's just a few of them that are blurred out that you can't actually see. This is another piece by Josh Bagley. It's called Good Luck with the Law, and it's using the same technology of looking at Google Maps satellite view to map the US-Mexico border to see how long it would take to build a border wall along the entire border. So this is a video I can play a little bit of, and then I'll link to as well. So it just keeps on going and going and going for about like 5 or 6 minutes. So it's a very long stretch of border that we have there. This is a piece by Rafael Lozano Hemmer. It's called Pulse Park and was actually on display in New York City probably 7 or 8 years ago. And it's another video. Let's play that real quick. So I'm going to skip ahead. So basically, this artist set up all these lights around this park, Madison Square Park, and there was a device at the front of the park that is a heartbeat sensor. So anyone could walk up to the sensor, grasp it with their hands, and then after a few seconds it'll detect their heartbeat, and it'll flash the lights in the park based off of their heart rate. If there's no one using it, if they remove their hands, and it stores all that data from the last 100 participants, and it'll flash all the heart rates, all the heartbeats of the last 100 participants in the park. So this is taking heart rate data and then visualizing it using light, which is very beautiful. So Dan Goods is a visual artist at NASA and uses NASA data to create some amazing artwork. This is called Pulse and is visualizing all the data that NASA sends and receives from the International Space Station. So the lights moving up are messages sent, and the lights coming down are messages received. And then if there's no messages being sent or received, then there's some graphics that show up as well. So Rafik Anadal is an amazing artist using machine learning and large amounts of data to create these beautiful visualizations. So this one is called Machine Hallucinations. Let's skip ahead a little bit. So again, it's using artificial intelligence and machine learning and large amounts of data to create these visualizations. A lot of them are based off of image data and images taken over a long period of time in different cities. It's based off of lots of other data sets too, but it's a mass amount of data that then gets projected on walls or buildings. It's really beautiful work. Okay, So now I want to go over Data Visual, which is the data visualization design platform that I developed and that we will be using as one of our tools in this class to create and design data visualizations and information graphics. So you should have an account on beta.datavisu.al already, that we're going to be using the beta site, not the live site. Just keep that in mind. And you should have an account, and you should be tied to our Queen's College account, which gives you full access to all the capabilities that we have to offer. So basically how it works is you go to the site, you log in, and you want to make sure that that this doesn't say Explore, but it should say Queen's College, or it should say Queen's College. And that basically means that you're in the Queen's College team account, which would give you full access to all the capabilities that Data Visual has. So if you see Explore up here, then you want to hover over your name over here and then select Queen's College in the dropdown. If you don't see that there, then you're not a part of the team account and you need to contact me to be added to it. So the next step is to start designing something based off of a chart type. So if you hover over Create or click on Create, it'll give you some options for different chart types that you could start with. So there's a column chart, bar chart, stacked column, stacked bar, line, pie, area, scatter, bubble, and a map. So if you click on any one of these, then it'll take you to that chart type with a pre-designed template. So let's say we click on column. So if we click on column, then we have a template here that's pre-designed. It'll just randomly generate a design for us. And on the right-hand side, we have a templates tab. This templates tab is basically gonna allow you to save and select pre-designed templates that you want to reuse. You probably won't use this tab very much, if at all, but it's there if you need it. The next tab on the right is the Data tab, and this is where you can type in your data sets. You can copy and paste from Excel into Data Visual's spreadsheet as well. You can upload a Excel file, a CSV file, or a TSV file. You can do some things like move around the columns, delete columns, select multiple rows or multiple columns and delete. But ultimately the data should look similar to this. It should be cleaned up. So you have like a header column and a label column, and then the data for the rows and the columns inside. So it should look something like this for a bar chart or a column chart or a line chart. The next tab is the GUI tab. It stands for Graphic User Interface. So for anything that you want to change about the design or the content, like the text versus chart title, you want to use the GUI area. The general chart section is like, the title is kind of like the file name. So what you want to save it as. You can add tags in here for searchability. If you click on private, then you will only be able to see your charts. If you don't click on that, then they'll be shared with the rest of our team, which is the Queen's College team. Then you could change stuff like the width of the chart, the height of the chart, the margin, kind of the padding around the chart, the max and min values. You can override that if you wanted to. The number of ticks, the data type, so if it's a number, a percent, or a currency, decimal place if you only want to have the first decimal place or you want to go more. And then you could also abbreviate values. If you're using billions or millions, you can abbreviate those values. So there's lots of other folders in here that you could click through. But honestly, the best way to modify anything is to click on it, and then it'll open up the folder that applies to, like if you click on the bar, it'll open up the folder that applies to the styles of that bar. So if you wanted to change the color of that bar, or the width or something like that, then you can just click on it and it should pop it up automatically. Otherwise, you would have to go through each one of these folders and like click it open and close to see what's in there, which isn't the most efficient way to use Data Visual. So there also is an interactive tab, which we aren't really going to get into until the second half of the semester for like hover states and stuff like that. But you can do hover states and change the value that's in the hover, change the type size, change the color, etc. Also for web-based visualizations, you can animate them on load. Again, we'll talk about that in the second half of the semester. You probably won't touch the interact or animate tab until week 8 or 9. Then on the left-hand side, if you hover over save, you should see save as new chart, save as new template, and maybe save as an organization template. I think you only see that if you're a certain type of user. So you're probably only going to see save, save as new chart, and save as new template. So save is grayed out because this is a new chart that I'm creating, or a new template. So you would have to save this as a new chart, and then you can go back in it and make changes and then save and override that. So the difference between a new chart and a new template is a template only saves the design. It doesn't save the data. So if you want to design a template and then upload multiple data sets to that template and reuse it, you can. Most likely you're probably just going to be using save as new chart, and that saves the design as well as saving the data. Then if you hover over export, when you're ready to export it, you can export low-res JPEGs, then high-res PNGs, high-res JPEGs, and then also vector files as PDFs, SVGs. And then you can also export web embeds. But we aren't going to be doing that until week 8 or 9. So if you only see low-res JPEG available, everything is grayed out, then you need to either make sure that you are in the Queen's College team account, so it should say Queen's College over here, or if you don't see that, then you need to contact me and I can add you to the team account. So let's go ahead and do a quick demo using some publicly available earthquake data, which is kind of cool. So I already exported all this data for us to use and put it into multiple file formats and different views of that data for us to play around with. And when it comes to like time-based data or categorical data or geographic data. So I will link to all that data, which can be found as a zip file that you can download and play around with on YouTube description as well as on the class website. So let's check out that data and start playing around with Datavisual. So here's all the data that we're going to be playing around with today. So there's the 2017 earthquake data. So this is the entire data set that I exported. So there's a lot of information in there. And then I looked at it in multiple views. So I'm looking at it by country. So around the countries that had the most earthquakes, looking at earthquakes by time of day. So how many earthquakes we had by time of day, and based off of if they were 5 to 6, 6 to 7, 7 to 8, or 8 and above magnitudes. Then I also have the latitude and longitude points, so we can plot them geographically. I also have the data by range, by magnitude range, so the majority of them were smaller. There's only one that was 8 plus. And then I'm also looking at them by month too, so if time of year has anything to do with it, we can maybe look at that too. So again, I will post these online for you guys to download, and make sure you look at the link in the description on the YouTube channel, as well as the link on the class website to find out where to download this data so you can play around with it yourself. So let's go to Datavisual now and start playing with it. Okay, so let's go to beta.datavisu.al. Remember, we're using the beta site. And then let's go to login, because you guys should have already signed up and have been added to our Queen's College team accounts. So log into your account. So when you log in, you might see create and explore up here. And then on the right-hand side, you might see your name, most likely. So if you see explore up here, that means you're in your personal account, which we don't want to be in. We want to be in the Queen's College team account. So it should say Queen's College up at the top here. So if you hover over your name and then scroll down to find Queen's College, make sure that that circle is filled in. So if we click on that, then we should be in the Queen's College account now. So you would know that by seeing that Queen's College is there instead of Explore. So now we are in the Queen's College account, team account. So now you can use the platform to its fullest capabilities versus not being able to like export high-res images or web embeds. If you are uncertain what type of chart to use, you can click on the question mark, and it'll give you a description of that chart type, some sample data, so what the data should look like, and then a visualization example. And if you want to learn more, we link to the Data Viz catalog website as well. So let's do a column chart. So if you click on that, then it gives you a randomly created bar chart. So if we reload, then it should be a different one. Reload again, it should be a different one. Cool. So the first thing I want to do is just get my data in there. So we can either go to data and then import and find that data, or we can find it on our machine and then click and drag it to the browser. So I'm going to do that. I'm going to find it, then click and drag it, and then release, and then it should upload the data that way too. So you don't have to go to import, you can just click and drag the file and it'll update everything for you. So these are all the different earthquakes by magnitude range in 2017. So if we want to change the style, so let's say we want to change the background color, or let's change the bar color, we can either click on the bar or go to GUI, go to bars, and then change, or we can just click on the bar and it'll open up that window for us. So if we want to make it like red, we can do that. Same thing with the background. If we click on the background, it'll open that for us. So if we want to make that like black, I think that makes more sense for earthquake data. And then same thing for the text. If we want to change the size, make that a little bigger, you can do that. Change the font, you can do that as well. Same thing with these labels. If we want to rotate it, we can do that. Change the location, do that a little bit. So yeah, it's starting to look a little better. Starting to look a little bit more customized. And if we want to change this title, we say click on that and then edit the title. 2017 earthquakes. Hit OK. There we go. So if we like it, then we can go and hit Save as New Chart. But first I wanted to go to General Chart, and let's give this a title. Let's say 2017 Earthquake. And then you can give it a tag if you wanted to, Earthquakes 2017. So this is just like hashtags, so you can search by keyword. And then we can go and save it, and then it should overwrite it. Cool. So now we can just go to export and say we want to export this as a high-res JPEG. Let's do it to the desktop. And there we go. High-res PNG image that we can now put into our poster designs or whatever. Okay, looks good. So let's save that again, just make sure that's saved. So why don't we play around with some time-based data? So let's do a line chart. So if we hover over create, we can go to line. Actually, let's do an area chart. That might be a little bit more interesting. Go to area. And then we could play around, let's reload this, see if we get a different one. Okay, let's play around with this one. And then I'm gonna click and drag the months file. So this is showing you the months for the year of 2017 and how many earthquakes there were. So what we can do is, let's click on the background, and that pops up the general chart folder. And let's do stacked. We're gonna stack all these areas rather than unstacked. And then they're just kind of in front of each other, but you could stack them too, which makes sense because we want to see the total number of earthquakes, but also broken into the range of 5 to 6 magnitude, 6 to 7, 7 to 8, and 8 plus. And again, if you click on everything, you can modify it. So if we want to make this like black, we can change that, or a different color, we can change that. Make that one white. We can do that. Again, change the text if we wanted to. 2017 earthquake by month. Change the positioning if we want it centered. Let's change the font too. Cool. And then again, we could just export whatever we want. We can save it. I'm gonna give this a name. See, 2017 earthquake by month. And let's hit save as new chart. Awesome. So whenever you save a new chart, and if it's not private, it'll display in the charts area for the Queen's College team account. If you also go to profile, all of your charts will be in this profile area, as well as your templates if you have any. So you can click back and forth charts and templates, and you can delete them if you wanted to. You can open them again and make any sort of modifications to them, etc., etc. Okay, so why don't we do one more? Let's go to create and let's do a map. So let's do a global map. So if you click on the background, you can change the map type to do global. And instead of geolocation lines for the data type, I'm going to do geolocation points. And let's change the point colors. Make them red. Change the background color. Click on the background, let's make it black. Let's change the color of the countries. Let's make it gray. And then let's change the border color. Let's make it the same gray. I'm gonna copy that, paste that. Cool. And then let's upload our data. So I'm gonna use the lat long location file. Click and drag and drop. So these are all the different locations of where all the earthquakes happened in 2017. So you can play around with the dots if you wanted to. You can do it by point size. So it's going to change the size of the dot based off of the data. You can change the diameter, so make them bigger or smaller. You can change the opacity. So that's good for clustering. So we bring this down to a lower value, then we could see that the ones that have multiple earthquakes stacked on top of each other are going to be brighter versus the ones that are just like one or two. So it looks like the majority of them happen in like this area around the northern part of Australia, and there's a bunch in Mexico, and then South America as well. And then again, you can just go file, save as a new chart. And you can export. Let's do a JPEG this time. And we didn't save it as a name. That's why it's called Untitled Project. It's fine. And then let's check that out. And we have our map with all of our locations for the earthquakes for 2017. All right, so we'll talk about interact and animate in week 8 when we talk about the web. So let's not talk about that yet, but feel free to explore this. One thing to know about the data format for maps is that it has to be a label column, a value column, an address column, a latitude column, and a longitude column, even if you're not using all of these columns. So make sure that your file looks like this when you are setting it up in Excel or Google Sheets before you load it into Datavisual. Also, if there's too many data points, too many rows in the data, then you can't modify it directly in Datavisual. So you're going to get something like this, that the data is too big to edit in the browser. So you have to edit it separately and then re-upload it if you want to make any sort of edits. But I would also suggest that you do that anyway, by having an external file for all your data and then uploading that file to Datavisual rather than typing it directly into Datavisual or copy and pasting. It's better to have them separate just in case anything goes wrong. So feel free to Slack me or email me if you have any questions about the Datavisual platform, or if you're having issues getting into the Queen's College team account. I'll be happy to add you to it if you just contact me. All right, so that is pretty much all I have for you today for this video. Make sure you check out the class website for any class assignments or homework assignments that are due this week. And like always, feel free to email me or Slack me if you have any questions about this lecture or any other ones, or about using Datavisual or about your midterm project. I am around and happy to help. All right, I'll talk to you guys in the next one. Thanks.